Okay, guys, so this is not another problem on friction. The problem says the tractor has a weight of 4,400 pounds with the center of gravity at G. The driving traction is developed at rear wheel B, while the front wheel at A are free to roll. Okay, so this basically means that there is no mu A. Okay, if the coefficient of the static friction between wheel at B and the ground is mu, so mu S, which is the mu SB, is 0.5. Determine if it's possible to put at P equal to 1,200 pounds without causing the wheel B at B to slip or the front wheel at A to lift off the ground. Okay, so this is a tipping versus a slipping problem. So it wants to consider two cases. So the first case is if this P is equal to 1,200 pounds, what it costs will at B to slip. Okay, and also what it costs this A to tip, which is A lift off the ground. So first, so tipping versus slipping kind of problem. We always consider slipping first, slipping case first, and then tipping, and then compare the two. Okay, so for slipping, okay. So first, what I have to do is I have to draw the free body diagram. So I have NA right here, NB right here, FB. So 0.5 NB. It's going to the left since the motion is going to the right. Then I have the weight center of gravity G is 4,500 pounds. Okay, so I have all the necessary information I needed. So for this kind of problem, what we can do is that we can use the moment. We can take a moment. So since the first case is without causing wheel at B to slip, which meaning that we have to take a moment about point A to see that how will it affect at point B, if that makes sense. Okay, so let's just take a moment at A. So at A, I have this 4,500 pound multiplied by distance of 4, perpendicular to distance of 4 feet. That's going clockwise to A. Then I have a P that has a perpendicular distance of 1.25, and that's also going clockwise to A. Okay, I have this MB, perpendicular distance of 4 plus 2.5, so 6.5. That's going counterclockwise to A. Okay, two unknowns can do anything. So wait, hold on. Yeah, two unknowns right here. We can do anything because we don't know what P is and we don't know what NB is. Okay, yeah. So next thing, what we can do is that we can move to summation of the force in the X direction. That's going to be simple, which the X direction has this P will be equal to 0.5 NB, and just ignore this 1,200 pound right here. Okay, so this 1,200 pound right here is the P required. Okay. Okay, it's not necessarily the P value that we have to find. Okay. Okay, since acceleration force in the X direction, we determine that P is equal to 0.5 MB. So plug this back in. So negative 4,500. 4 minus 0.5 MB 25 plus MB 6.5. And this equation right there, there's only one unknown, which is just the MB. So solve this equation in terms of MB. So we get that MB is equal to 3,063.8 pounds. Okay. And then we know that since MB is equal to 3,063.8 pounds, and then P will be half of MB, where P will be just equal to 1,531.9 pounds. Okay. Okay, so that's the P without if this thing slips. Okay, but right now let's look at another case where this thing would tip. assembly line right here. So tipping. We know that there's no mu SA. Okay. So if there's no mu SA, then see. Okay, so if there's no mu SA, then there's no NA. Okay. All right. Okay. So right now, we have to take a moment about point B because the problem is saying the front wheel at A, if the front wheel at A will lift off the ground. So summation moment at B. So I have this P going to B, that's going clockwise with a perpendicular distance of 1.25. And then this 4,500 pound going to B with a perpendicular distance of 2.5 feet. And then that's going counterclockwise to B. So plus 4,500, let's go like 2.5 equal to 0. So solve for P. So I got P is equal to 9,000 pound. Okay. So right now, let's compare those two values, those P we found. Okay, so let me explain. So this P right here, that's amount of force that if we pull this tractor, that's how much for this tractor to slip, which to stay in motion. And this P right here, that's the amount of force that if we pull this tractor, that's the amount of that. I'm sorry, guys. So if we pull this tractor at 9,000 pounds, it means that this tractor would tip. Okay, if that makes sense. And then the question says determine if it's possible to put at P of 1,200 feet. So if we put this P at 1,200 pounds, what it costs this thing to slip? Either slip or tip. Well, we find out that it will not because P required is less than P slip. And less than P tip. Okay, so the answer is not. The answer is therefore it is possible to pull the load without slipping or tipping. Okay, so that's the answer for this problem. Okay, I'll see you guys in the next problem. Hey guys, so this is an internal force problem. The problem says determine the internal force. The problem says determine the internal normal force, shear force, and moment acting at point D, which is located just right of roller support at B. Okay, this one right here. We need to find normal force D, shear force D, and moment at D. Okay, usually he doesn't put those kind of problem on the final because usually in the previous semesters he never go over chapters 7 internal force. But since most of you guys right here will be taking CE 3400, and that's where you will get into those shear force diagram, bending moment diagrams and stuff. He wants you guys to have those initial knowledge of those kind of he wants you guys to have an initial knowledge of the materials. So that's why he throw in internal force problem. Okay. All right. So the first thing we need to do is we need to turn that. The first thing we need to do is that we need to turn the distributed load into the point load. Okay, we know that we can do that. Since those are all rectangular distributed, we know that the point will be directly in the center. Okay? And we know that that's simply just the load multiplied by the length, which for this one's 200 multiplied by 4 will be 800 pound of load. This one's 300 multiplied by A will be 2400 pound load. This one is the same thing, 800 pound load. Okay, so as you can see in the problem right here, there's 3 reactions with 3 unknowns. Okay, we don't know what AY is, we don't know what AX is, and we don't know what BY is. Okay, what we can do at this point, we know that we can take a moment about A, because that has the most unknowns. So do a moment about point A. So we got BY going counterclockwise, so that's positive, multiplied by the perpendicular distance of A. And then we'll have this 800 pound right here. That's going counterclockwise as well. So plus 800 perpendicular distance for 2 feet. Right here is 2 feet. Okay. And then have this 2400 pound right here. And that's going clockwise to A. So minus 2400 multiplied by the perpendicular distance of 4. Okay. And then have this last 800 pound as segment DE right there. So, and that's going clockwise to A as well. So minus 800 multiplied by 4 feet plus 4 feet plus 2 feet. So that's 10 feet right there. Then we can solve BY. I know that the BY will be equal to 2000 pound of force right there. Okay, so we find out what BY is. Okay. And then by doing that, we were able to determine what AY as well. But since this problem is only asking for a moment at D, and D is just located right above B. Okay, so which means that we can basically just cut a segment right here. So let's say this is D, this is E. Of ND, BD, and MD. Then the low is 800. 2 feet, 2 feet. Okay, so actually we don't need to use that BY, but if the problem in the exam is asking me to find out the normal force, shear force, and moment acting at any of other points, then it'll be wise for you guys to find out all the unknown reaction force, so that you have everything on your hand to solve the problem if the problem is actually for shear, normal, and moments at all other points. But for this one, we actually don't need to use the BY. Okay, so for this one, it's really easy. You can just simply take a moment about point B. Okay, and we know that this moment is going clockwise, so it will be negative, and then minus is 800 on the force multiplied by the perpendicular distance of 2 equals 0. And then we got that our MP will be equal to negative 1600 pound per feet. And then if we turn out to kip per feet, it will be negative 1.6 kip per feet. Okay, so it's very easy, but if the question is asking to find out the shear, normal, and moment about point C, then what you have to do is that you have to cut between E and C. Okay, don't cut it between C and D, because if you cut it between C and D, you need to know what MD is, you need to know what MC is. But if you cut it between C and D, since E is this hanging edge right there, we know that there's no moment right here. Okay, there's no internal moment, there's no internal shear, there's no internal normal force. But if you cut it between D, you have to take MD, VD, and ND into consideration on top of VC, NC, and MC. Okay, All right, so that's all for this problem, and I'll see you guys in the next problem. Okay, so problem A is asking for the trust shown, if the reaction at J is 15 kilonewton, the force in member FH is closest to what? Okay, so we know that Fj is equal to 15. Okay. And this is a method of section problem. Then we need to find out that what FH is. So let's call this section right here, depending on what FH here is. Okay, so we can either pick left side or right side for analysis. Obviously, for this problem, we have to pick the right side because the force J, for no confusion, let's say it's JY, not FJ. Okay. All right, so for this problem, we're going to pick the right side because if we pick the left side, we don't know what BY is. We don't know what BX is. But we can solve it. And even if this problem doesn't give us what JY is, we can solve for JY by simply just consider the whole structure and then take a moment about point. Okay, so let me just draw the three-band diagram for the right side. Point G, point I. H, point J, and each panel is 2.4 meter. This is 2.4. Okay, and then so I have this FH right here, and then BSH. Okay, so this problem, since it's only asking for FFH, it's not like previous method assessment problem where it's actually also asking for maybe FFG, FEG. Okay, so for this problem, we simply can just take a moment about point G, and then so that we are able to solve for FFH. And then a moment about G, we have this 15 kilonewton that's going counterclockwise to G, so that's positive, with a perpendicular distance of 2.4. Okay, and then we'll have this FFH as well to G, that's going clockwise, so that's negative. Perpendicular distance of 1.8 meter equal to 0. So we have the FFH be equal to 20 kilonewtons. Okay, and that's in tension as well. Hey guys, so that's all for this exam review. So I went over 8 problems. So the first 3 free response problem that he will give you on the final. The first one will be mobile inertia. Second one will be friction. Third will be frames and machines. And then for the other 5 multiple choice, he'll give you fluid. What's the other few? So he did fluid, internal force, method sections, another friction problems, and the 3D central. Yeah. So that's kind of problem that he'll give you an exam. And then so this exam we are basically just going over the type of problem that you're gonna expect or level of difficulty that you're gonna expect on the final. Okay. So good luck to the final, and yeah, I hope I don't see you guys in this class next semester.